Saxon's Trig lesson 105 is about cofactors and then expansion by cofactors. So when we had our discussion about matrices, and we did a 3 by 3 one, and we were solving for the x, we had 3 columns where we had our answers, then our y's, then our z's, and then we had to repeat the first 2 lines and do our Florida to Canada to get our determinant. Now, a mathematician, or multiple mathematicians, but in the past, they were playing with these things and they discovered a unique little pattern that emerged that got called cofactors. And so what they discovered was that if in a matrix you want to find some information about this number here, they eliminated it, both row and column, and the 4 numbers that were left, they found the determinant, and then they multiplied it by this number, and they also alternated the signs. So again, it took them a while to figure this out. They got the same answer as they did the other way, and they called it cofactors. So let me first give you the pattern for the signs, and once you know where it starts, you don't have to write it every time. You can just mentally count it out. So it always begins with a positive in the first row and column, and then it alternates negative, positive, negative. And so you can go for however many rows and columns you need. Then underneath, negative, positive, negative, positive. I'll do one more. Positive, negative, positive, negative. So as long as you know the first place is a positive. So whatever answer you're crossing off, so if you were doing row and column here, then this answer would be in its positive format. If you were doing row and column here and eliminating this number, you would be changing the sign of the answer that you got. You would be negating that. Now, example 1 on page 592 says, find the cofactor of 7 from the following determinant. Oops, they give me 4, 2, 2, 7, 5, 1. 3, 6, and 5. And so they said they want the cofactor of the 7. So where is the 7 in my list of numbers? It's here. So we're going to get rid of row and column that contain the 7. Here then are the numbers that we are going to use, although they don't want me to take it down to its answer. They just want me to show what the cofactor looks like. Now, in this one, if my first one is always positive, then this 7 is in the negative spot. So I know I'm going to have a negative of the parts that were left. 2, 2, 6, and 5. So when it asks me to find the cofactor, it's just asking for write it out, not actually solve it. Now in part B, the expansion by cofactors, they are going to have us do more of the answer work. So use the cofactors to evaluate, this is example 2, to evaluate this determinant. So we have -4, 1 and -1, 2, 3, and 2, and then 1, -2, -3. Okay, so I have to choose whether I am doing the top row or the bottom, or middle row, or I have to choose which row I want to eliminate. If I have zeros in the problem, I want to keep as many zeros as I can with my leftover parts. Since this one doesn't have any of those, it really doesn't matter. They just made a choice, and so to kind of match what the book does, they chose to do this bottom row. So we are going to first do the row and column. So we know that we have the -1 in that spot, and we check the sign, positive, negative, positive, so we're going to leave that alone. And then what we have left is the 2, 3, 1, and -2, and we'll come back to fixing that in a minute. You're going to add to the next one where we got rid of this one. So now it's a 2, and we check our sign, positive, negative, positive, negative. Oh, okay, so this is actually -2 multiplying with, and then what were the pieces not gotten rid of? Well, that would be the -4, 1, 1, and -2. Adding with, and now I need this last one, -3, and then positive, negative, positive, negative, positive. So we're going to leave that alone. And then what if we get, whoa, sorry about that. Let me see if we're still, okay. If we get rid of this one, then we are keeping the negative 4, 1, 2, and 3. Okay, now that we have those, let's go ahead and fix these numbers with their determinant like we know how to do from before. 2 times negative 2 is negative 4. 3 times 1 is 3, but we changed the sign going to Canada. So that gives us negative 7 times negative 1. So we have 7 plus. Okay. Then here, negative 4 times negative 2 is 8. Don't change the sign. 1 times 1 is 1. Changing it to minus 1. 8 minus 1 is negative 7. Negative 7 times negative 2 is, just a second. That's not negative 7. 7 times negative 2 is negative 14 plus, and now we do 1 times 2 is 2, change the sign to negative 2. Negative 4 times 3 is negative 12, so negative 14 times negative 3 is positive 42. I want to just check that again. 14 and 3. Yes, okay. Then put these answers together and we get 35 for the overall answer. Now, example 3. Use cofactors to evaluate. Negative 3, 2, 0. 1, negative 3, 4. 2, negative 4, negative 5. So which do we want to get rid of? Now, I said I like to keep my zeros, but they chose to go ahead and let's get rid of this bottom again. Creatures of habit they are. So this first one with the 0 times anything gets thrown out. So it's still helpful to eliminate the 0 one. All right, so now we're eliminating this one. So we are keeping the 4 and positive, negative. So negative 4 with, and since we're losing that one, negative 3, 2, 2, negative 4 plus, and then the last one is negative 5, positive, negative. Yep, keep it negative 5, and then that is keeping negative 3, 2, 1, and negative 3. All right, then negative 3 times negative 4 is 12. Florida, keep it. 2 times 2 is 4, negative. So that would be 8 times negative 4. So our negative 32. Negative 3 times negative 3 is 9. Leave the sign. 2 times 1 is 2. Change the sign. 7. 7 times negative 5 is negative. Just a second. 7, yes. Nope. Oh, yes, there it is. Oh my goodness gracious. Yes, negative 35. Oh, I went to the wrong example. No wonder that threw me. And then combining those two negatives together, negative 67. Okay. And now we have one more example. Use cofactors to evaluate. Negative 3, 2, 1. 1, negative 3, 4. 2, negative 4, 0. And they are going to lose their zeros. So for the first, I almost want to work it backwards. I'm not. All right, so this is a 1 that's being lost, positive, negative, positive. All right, and it is going with, if I'm losing this one, 1, negative 3, 2, negative 4, plus, then the 4 is in the spot. So positive, negative. So negative 4 going with negative 3, 2, 2, negative 4 plus, and then that 0 doesn't keep any of that last piece. All right, 1 times negative 4, negative 4, negative 6, change the sign, positive 6. That's 2 times 1, so that's just a 2, plus negative 3, negative 4, positive 12, 4, make it negative 8, negative 16. And then that should be, oh, uh-oh. Should be the same even if I don't eliminate the same thing as they did. Was in my very, very last multiply. I said 8 and then 8 times negative 4, and I wrote something totally different. 8 times negative 4 should be negative 32. 2 minus 32 makes an answer of negative 30, which is exactly what we wanted. And I said it didn't matter which row I chose to get rid of, so they chose to do the one that had a 2 and negative 4. Oh, yeah, they chose to do it this way, which to me feels more complicated, but you still should get the same answer as I said.